Good morning. Good morning, guys. Today I explain the rest of chapter 1 wave motion. A wave produced from a vibrating source or vibrating body. For example, spring or pendulum vibrate, or tuning fork or string. This is vibrating body or source of waves, source of vibration. Okay. To produce the mechanical waves, we need three factors. Number one, vibrator or source of disturbance of the source of wave, like vibrating body. Number two, the second factor, kind of disturbance that can transferred from vibrating source to the medium, or kind of disturbance, I mean how the wave travel or how the wave disturb. The wave disturbed by two kind, transverse or longitudinal. I promise you to explain the difference between them in the previous session. Number three, kind of medium. Kind of medium that carry the disturbance. Medium, I mean air, gas medium, or liquid like water, or solid like metal or wood. This is medium, kind of medium. So medium, I mean medium divided into three types: liquid or solid or gases. Okay. Kind of disturbance, I explain that now. Disturbance, kind of disturbance, the wave or the disturbance in the medium can travel by two ways. The wave move by two ways, like the human move by two ways. Man has certain method or certain way to move, and the female or the woman move by another way, or walk by another way. Okay. The wave, like the human, has two kind of move, two kind of motion. Not by female or male, but transverse or longitudinal. Types of mechanical waves can travel by transverse or longitudinal, but electromagnetic waves propagates by longitudinal waves only. Okay. What's the meaning of transverse wave? Transverse wave like this. Wave up and down, up and down, up and down. I mean particles of medium move up and move down, move up and move down, move up and move down. If the wave propagates from here to here in this direction, so the motion of the particles of the medium is perpendicular to the direction of the wave propagation. Like water wave. Water wave move by this way, transverse wave. Transverse wave consists of two move or two point, crest or trough, crest or trough, crest and trough. Crest is the maximum amplitude in positive direction. Trough is the maximum amplitude in minimum, or a maximum displacement, I mean amplitude, maximum displacement or amplitude in negative direction. Okay. The distance between crest and successive crest, or trough and successive trough, is called wavelength. Wavelength, distance between two successive crest or trough, two crest or two trough. I said example for transverse wave, water wave, or stretched string, or rope motion. When catch the rope and tied another side of rope and move the rope by this way, this is transverse wave. Okay. The second type, longitudinal waves. Longitudinal waves, like spring waves, make waves closed from each other and area the wave inside it far from each other and closed in the next area, and so on. This is the particles of medium closed and far, closed and far. So the particles of the medium vibrate in the same direction of propagation and consist of compression and rarefaction. Compression and rarefaction. This is rarefaction and this compression. Okay. The distance between center of compression to the successive compression, or center of rarefaction to the successive rarefaction, is called wavelength. Not condition center. May I say from first to first? At the first or the beginning of compression and the beginning of next compression, or the end of compression to the end of compression. This is called the wavelength. Okay, distance between centers of two successive compression or rarefaction, or the beginning to the beginning, end to the end. Okay, start to start, end to end, and so on. Example 2, longitudinal waves, sound wave or spring sound wave. The tongue vibrate the air like closed to it and make these waves in the air like this shape. Rarefaction or compression. Okay, compression following rarefaction, compression and rarefaction. Okay, sorry. So the wavelength has two definitions. The first, the distance between two crests or two troughs in transverse wave. Second, in longitudinal waves, distance between center of compression, two compressions, two successive compression, or two successive rarefaction. But the definition of the wavelength in general, or distance between any two successive points having the same phase, I mean the same direction, positive or negative. Crest in the direction of positive, or trough in negative direction, okay, or negative region, sorry. So the wavelength equal distance over number of waves. If you have you has this wave consists of crest, trough, crest, trough, crest, trough, and so on, and drawing x-axis and y-axis. On the y-axis displacement, right displacement, and here distance, okay, or right distance like that. For example 40 meter, يبقى ال wavelength equal 40 meter divide number of waves. What is the number of waves? Up and down 1, up and down 2, up and quarter, يبقى 2 waves and a half and a quarter, يبقى 3/4. This is the number of waves. Distance 40, يبقى wavelength equal 40 over 3/4 or 2.75. This is the number of waves. Okay, but when draw the waves in this method. In this method, circles. The radius of this circus, of the first radius of the first circle, this is the distance. This radius equal distance. And the number of waves, 1, 2, 3. Okay? Relation between the frequency and wavelengths, frequency, wavelengths, and wave velocity. We know from the previous years, velocity equal distance or displacement over time. Our speed equal distance over time. Distance like wavelengths, the distance of one wave. Time, it is the periodic time. We know periodic time taken to make one complete oscillation. When drawing one complete oscillation, this is the periodic time. And this is the one wave. One wave, I mean the wavelength. Okay, I said the wavelength, distance between two successive crests. Cancel its part and added this part instead of. But the distance, this wavelength, we can say the wavelength, the length of one wave, okay? When put this area instead of this area. But the wavelength, distance of one wave. One wave takes time, periodic time. So, instead of x, put wavelength. And the periodic time instead of the time. يبقى V equal wavelength divide periodic time. I know frequency equal 1 over periodic time, so periodic time equal 1 over frequency. يبقى V equal lambda divide instead of frequency instead of periodic time. 1 over V equal 1 x lambda over periodic time, 1 over frequency instead of periodic time. divide time يبقى equal wavelength time الفrequency. يبقى velocity equal wavelength time frequency. This is a very important law, and this law also used in the problem. Thanks and goodbye.